You wake before sunrise, and for one strange second, the world seems ordinary. The street outside is still there. The buildings still stand. The horizon still waits for morning. Then your chest tightens. You try to inhale, and nothing answers. No wind moves the trees. No distant engine murmurs. Above you, the sky is not blue, not gray, not even dawn-colored, but black, crowded with stars, while the sun burns like a hard white wound over a silent earth. In that instant, the planet has become something else. Because an atmosphere is easy to ignore, it is invisible, weightless to our senses, always there, yet it softens sunlight, carries sound, shapes weather, holds warmth, feeds fire, protects liquid water, and gives every breath its meaning. Remove it, and the familiar world does not simply become uncomfortable, it becomes alien. Streets turn into exposure zones, oceans lose their calm surface logic, day and night grow harsher. The ordinary systems that make Earth feel gentle, livable, and known begin to fail all at once. Science understands this invisible envelope remarkably well. We know what Earth's atmosphere is made of, how pressure allows water and air to behave the way they do, how oxygen reaches the blood, and how the sky itself gets its color. We also know that without atmospheric pressure and protection, the surface of our world would behave far more like a bare planetary frontier than the home our species evolved to trust. So while this scenario is hypothetical, the physical principles behind it are very real. That is what makes this question worth following, not because it is fantasy for its own sake, but because it reveals how much of life depends on things we never see. What if Earth lost its atmosphere? What would happen first to your body, then to cities, to weather, to oceans, to animals, and finally to the planet itself? Step by step, cause by cause, the answer takes us through one of the most extreme transformations a living world could suffer. It also lets us compare our world to Mars, to the Moon, and to the airless silence found elsewhere in the solar system, while reminding us that Earth is not habitable by accident, but by a balance that can be described, measured, and lost. And that journey is more than a disaster story. It is a way of seeing Earth clearly, by imagining the sudden absence of the thin ocean of gas that separates life from cosmic emptiness. If that sounds like a journey you want to take tonight, gently like this video, subscribe to the channel, and tell me in the comments where in the world you are watching from. Now, lower the lights, settle into stillness, and take one slow, easy breath while you still can. Let the noise of the modern world drift away. Let the room grow quiet around you, and together, let us step into the strangest morning Earth could ever know. The first instinct is not thought, but hunger. Your body reaches for air before your mind has even decided what is wrong. The muscles of your chest pull inward, the throat opens, the diaphragm drops, and the ancient machine that has kept every human alive since birth performs its simplest command. But the breath does not come. The motion happens. The answer does not. What follows is not like drowning, and not like choking. Drowning gives you water where air should be. Choking gives you obstruction. This is stranger than both. Here, there is simply nothing useful to take in. No invisible reservoir around you. No ocean of gas pressing gently against skin, eyes, lungs, and blood. The world has not filled with danger. The world itself has become the danger. That first moment would feel impossible, because it would overturn a promise so basic
that most people never notice it exists. Every second of ordinary life is built on a quiet agreement between the body and the atmosphere. You inhale, and oxygen enters. You exhale, and carbon dioxide leaves. Pressure holds the delicate surfaces of the lungs in the range where they can do their work. Warmth lingers near the ground. Sound travels through the air from one person to another. Fire burns when fuel is present. Clouds gather. Rain falls. Birds cross the sky. None of these things seem miraculous while they are happening. They feel normal only because they happen all the time. But remove the atmosphere, and normality vanishes in the same instant. The frightening thing is how quickly the human body reveals its dependence. Before cold, before hunger, before thirst, before any
longer catastrophe can fully take shape, there is the immediate reality that you cannot remain conscious for long without oxygen. The brain is not patient. It consumes a remarkable share of the body's energy, and it depends on a constant flow of oxygenated blood. Interrupt that flow, even briefly, and the higher functions that make you feel like yourself begin to dim. The carefully ordered world of language, memory, choice, and recognition starts to flicker. This is one reason why the disappearance of atmosphere is not a slow disaster at first. It is not something you study from the porch with growing concern. It is something your nervous system understands almost at once, with a force that bypasses reflection. In imagination, many people picture such a moment in dramatic, cinematic extremes, as if the body would burst apart the instant the air vanished. In reality, the truth is more sober, and therefore in some ways more unsettling. A human being exposed to near vacuum would not explode. Skin is stronger than that. The body is not a balloon waiting to pop, but that does not make the situation survivable. Without surrounding pressure, gases behave differently. Moisture evaporates more easily, and the tissues that depend on a normal atmosphere are pushed far outside the conditions in which they evolved. The lungs are especially vulnerable. If a person were foolish enough to hold a full breath during sudden decompression, the expanding gas could injure them badly. The safer reflex, difficult though it sounds, would be to exhale. Even then, the loss of useful oxygen would be brutally fast. The eyes would sting. Moist surfaces in the mouth and airways would begin to dry and boil at body temperature in a way that sounds theatrical, until one remembers that boiling is not about heat alone, but also about pressure. This would not mean that the body's blood would suddenly bubble away through intact veins, as popular myths sometimes suggest. Internal tissues remain under their own pressures, but exposed moisture would respond to the new environment immediately. Saliva, the wet surface of the tongue, the lining of the nose, the film covering the eyes, all would begin to behave in unfamiliar ways. Swelling could occur as dissolved gases came out of solution in tissues. The skin would not split, yet the whole body would feel as if it had been pushed beyond the edge of nature, into a place no animal was meant to visit. And still, even these details remain secondary to the simplest fact of all. The first killer is oxygen loss. It is tempting to imagine that you could prepare by taking one heroic final breath and holding it, but that instinct belongs to life underwater, not life in vacuum. The lungs are built to exchange gases with surrounding air at pressure, not to store long-term rescue inside the chest. A breath held under these conditions becomes a liability. What matters more is time, and there is very little of it. A person suddenly deprived of breathable air would remain aware only for a short interval before confusion, weakness, and unconsciousness took over. The exact number would vary with condition and circumstance,
But the point is not the count. The point is that it is measured in seconds, not in thoughtful minutes. This is why the first phase of such a world would be defined by unfinished actions. A hand reaching for a door that is never opened, a phone lifted but never used, a parent turning toward a child, a driver pressing the brake too late, a surgeon standing over a patient, a teacher in mid-sentence, a pilot scanning instruments, a swimmer near the surface, a sleeper opening one eye in bed. Earth's great cities, so proud of their speed, would discover how much of their intelligence depends on the simple fact that people can stay awake. When the ability to remain conscious collapses, all higher coordination collapses with it. Traffic systems, emergency services, hospitals, markets, airports, control rooms, trains, factories, data centers, and homes are all only extensions of human minds and lungs. Take away the atmosphere, and the network loses its operators before it has time to understand the failure. Yet, before many people even lose consciousness, they would notice something else, something so eerie that it might remain unforgettable even in those few last lucid seconds. The world would become quiet, beyond all ordinary quiet. Silence on Earth is never complete. Even at night, in the most remote places,
Air continues to carry tiny lives and distant movements. Leaves whisper, water moves. Insects pulse in the dark. A dog barks across a valley. Your own clothes shift with a faint sound. In a world without atmosphere, that familiar medium is gone. Sound cannot travel through empty space the way it travels through air. Vibrations can still pass through solids touching your body. You might hear the scrape of your own hand against a wall, the thud of your own heartbeat conducted through bone, the faint internal roar of blood and muscle. But the open world around you would fall silent in a way that no forest, desert, or snowfield has ever been silent. This matters because human beings use sound not just to communicate, but to orient themselves emotionally. Sound confirms distance, scale, danger, shelter, and company. It tells you whether the world is alive around you. A world that goes silent does not merely become peaceful, it becomes uncanny. You could see another person only a short distance away, mouth open, arms moving, and hear nothing of their voice. A collapsing streetlight, a shattering window, the rolling body of a car, the desperate impact of fists on glass, all would lose their usual soundtracks. In ordinary disaster, there is noise, and noise creates shared reality. In this one, there would be visual chaos wrapped inside impossible stillness, as if the planet itself had suddenly stopped answering. Then there is the sky. For most of human history, the sky has been one of our oldest clocks, our greatest ceiling, and one of our deepest emotional landscapes. It changes with weather and season, with latitude and time of day. It softens sunlight into blue. It scatters red into evening. It hides the stars behind brightness. All of that depends on air. The blue of day is not painted onto the heavens. It is a product of sunlight interacting with molecules and tiny particles in the atmosphere. Remove that atmosphere, and the familiar vault over Earth disappears. The sun remains, light remains, but the sky darkens toward black because there is no broad veil of air above you to scatter daylight across the dome of vision. In full day, stars could appear. The moon, if visible, would hang in a black field like an object seen from orbit, not from home. This visual transformation would be one of the most immediate signs that Earth had stopped behaving like Earth. A black daytime sky
is not just unusual, it is psychologically wrong. Human beings are creatures of atmosphere in every sense. Our emotions are tuned to haze, glow, distance, brightness filtered through air. Even mountains are beautiful to us, partly because atmosphere softens them into layers. Without it, edges grow harsher, horizons become more severe. The world appears closer and farther at once, more precise and less welcoming. The sun itself becomes more dangerous to look at, a fierce disk without the familiar drama of a bright sky around it. Shadows would be hard-edged. Light would feel less like a bathing presence and more like direct exposure. The same atmosphere that paints the sky also moderates sunlight. It absorbs and scatters part of the incoming energy, especially in ranges of radiation that are harmful to living tissues. Without it, the surface is no longer gently wrapped in filtered daylight. It is struck more directly. But here again, the sequence matters. The first human crisis would come too fast for radiation damage to become the immediate concern for most unprotected people standing in the open. What matters first is that the disappearance of atmosphere makes the world not only unbreathable, but visually alien, acoustically broken, and physically unbuffered. A person looking up long enough to register the black sky and hard sun would be looking at a planet whose protective envelope had been stripped away. For those who were indoors, the experience would depend on the structure around them. A sealed, pressurized environment could preserve life for a time. Most ordinary buildings, however, are not miniature worlds. They are not designed to maintain internal atmosphere when the entire outside environment vanishes. Windows would become points of immediate stress. Doors, ducts, vents, and every small weakness in construction would matter. In some places, the loss of outside pressure would create violent movement of air as interior rooms tried to empty themselves into the new vacuum beyond. Loose objects might be pulled toward openings. Papers would
lift, curtains lash, doors swing with terrifying force. Yet again, the violence would vary. This would not be a single movie scene repeated everywhere. It would depend on how sealed, strong, and compartmentalized a space happened to be. That detail is important because real disasters are rarely uniform. They are mosaics of physics, structure, chance, and location. A person in an open field would face one pattern of danger, a person in a small car another. A passenger plane at cruising altitude is already in an environment where outside air is too thin to support human life, which is why the cabin must be pressurized. Lose cabin pressure there, and the emergency is extreme, but conceptually familiar. Lose all atmosphere at the surface of the planet, and the whole Earth becomes a decompression zone. Elevators, subways, tunnels, office towers, farmhouses, and shopping centers would each interact with the event differently. Some spaces would become temporary traps. Others would become brief shelters. Almost none, without preparation, would become long-term sanctuaries. Cars offer a revealing example of how much modern life is not truly sealed. Sitting inside a vehicle can feel like being enclosed. In reality, a normal car is full of designed leaks and exchanges with the outside world. Air enters through vents. Doors and windows are not pressure chambers. Engines that burn fuel rely on oxygen from the atmosphere. If the air were gone, most ordinary combustion engines could not continue functioning as they do now. A car in motion might roll on inertia for a moment, then become little more than a metal shell. The person inside would not have found a submarine. They would have found a thin container inside the catastrophe, buying perhaps seconds of altered conditions, not rescue.
Aircraft would reveal the same truth on a grander scale. We often think of planes as conquerors of the sky, machines that make the air their highway. But flight, as we know it, depends on atmosphere at every level. Wings need air flowing over them to generate lift. Jet engines and propellers interact with air. Remove the atmosphere, and the sky stops being a navigable medium. It becomes emptiness. A plane already in motion would not simply continue happily through a vacuum. It would lose the very substance that makes aerodynamic control possible. For aircraft aloft, when the change occurred, the situation would be catastrophic. And because flight symbolizes mastery, its failure would carry a special emotional weight. One of humanity's proudest relationships with the air would end the instant the air itself ended. At street level, the collapse of combustion would spread into the city almost invisibly. So much of modern civilization is powered by reactions that assume oxygen is present. Engines, stoves, heaters, furnaces, industrial processes, and countless small flames depend on it. Fire is one of the oldest companions of human life. It cooks food, hardens metal, warms homes, lights darkness, and marks ritual. Without atmospheric oxygen, ordinary open flame cannot continue. A candle would not flicker heroically and then recover. It would die. Gas burners would fail. Torches would vanish. The long history of fire, from campfire circles to refinery towers, would come to an abrupt end on the exposed surface of the planet. A species that once defined itself by controlling flame would find that fire had belonged not to us alone, but to the partnership between fuel and air. All of this gives the first phase of the event a particular emotional character. It is not only lethal, it is also disillusioning. One by one, the quiet assumptions behind human life are exposed. We do not merely breathe. We depend on pressure, composition, circulation, and shielding. We do not merely hear. We depend on a medium carrying vibration. We do not merely see the sky. We depend on molecules above us scattering light into a livable dome. We do not merely use machines. We depend on air for engines, lift, fire, and thermal behavior. The atmosphere is not one system among many. It is the stage on which nearly all surface life and surface civilization perform. This becomes even clearer when we think about pressure itself. Because pressure is invisible, it rarely enters ordinary imagination. Yet the atmosphere presses on everything around us all the time. At sea level, that pressure is substantial, though our bodies are so well adapted to it that we do not experience it as crushing.
Instead, we inhabit a balance. Internal pressures and structural strengths meet external pressure in a stable arrangement. Water remains liquid in ordinary conditions, partly because of this balance. Lungs expand and contract within it. Blood gases dissolve in tissues under it. Take away atmospheric pressure, and countless familiar behaviors shift. The body is not merely deprived of oxygen, it is moved into a physical regime for which it was never built. This is why the open ocean, so often imagined as refuge or vast reserve, would offer no easy sanctuary. A person on a boat would not find safety simply because water remained nearby. Surface waters, exposed to the new vacuum above, would begin to respond in unsettling ways. Pressure affects boiling point, and without normal atmospheric pressure, the outermost layer of water could begin to boil, even at temperatures that ordinarily feel cold. That does not mean the ocean would instantly disappear into steam. Oceans are too large, and thermal processes too complex for such a cartoon ending. But the calm logic of the surface would be broken.
For someone standing on a shore or a deck, the familiar relationship between sea and air would already be gone. The ocean would no longer feel like a companion to the sky. The sky would have vanished as a fluid partner, leaving the water exposed to a new and hostile reality. But once again, for human beings caught without protection, these larger planetary consequences would mostly unfold beyond the first horizon of survival. The body's crisis comes first, and that crisis would differ depending on whether some source of pressure and oxygen remained nearby. This is where the geometry of survival narrows into a handful of desperate possibilities: a pressurized laboratory, a spacecraft-style module, a diving bell, a submarine, a hyperbaric chamber, a sealed industrial compartment, certain military or research facilities, perhaps, in rare circumstances, parts of underground systems with robust air handling and isolation. What these places share is not comfort, but enclosure. To survive beyond the first minutes, you would need not simply a room, but a machine-made fragment of Earth, a pocket where gas, pressure, and temperature could still be controlled. The difference between a shelter and an ordinary interior would become one of the great dividing lines of the event. Many people today live in spaces that feel protective because they keep out rain, wind, and seasonal cold. But a world without atmosphere asks more of shelter than a roof and walls. It asks for seals, pressure integrity, stored gases, filtration, valves, structural resilience, and some capacity to regulate conditions over time. In other words, it asks for habitat engineering. Most human buildings are not habitats in that strict sense. They are homes built inside a living planet that already performs the hardest work for free. Remove the planet's support system, and most architecture reveals its dependence. Consider how strange this would be psychologically. For thousands of years, people have looked at stone, brick, timber, and concrete and trusted that solidity means safety. In this event, safety would no longer correlate simply with thickness or mass. A cathedral of stone might become a trap if it could not hold pressure. A modest technical chamber with airtight seals and life support reserves might become a castle. Old intuitions about protection would fail. A man in a heavy coat on an empty avenue would look prepared for winter and yet have almost no chance. A scientist in a small sealed module with oxygen supply, pressure control, and communication systems might endure. The age-old idea of shelter would be rewritten in an hour. There is also a cruel hierarchy in which people would survive slightly longer. Those already using pressure suits, certain diving systems, or specialized protective equipment would gain a precious advantage. So would those working in aerospace, undersea research, some military contexts, and a few extreme industrial environments. Astronauts train for the truth that life is possible only inside carefully maintained bubbles. Most people are never asked to think that way. If Earth lost its atmosphere, the astronaut's view of reality would suddenly become the human view of reality. The entire surface world would be transformed into hostile outside. The ordinary street would become as lethal as an airlock left open to space. Yet even the people
Inside genuine shelters would not be safe in the larger sense. They would be alive, yes, but not restored. Their situation would resemble survivors aboard a damaged vessel, not inhabitants of a functioning world. Any enclosed refuge depends on supplies, power, maintenance, and time. Oxygen must come from somewhere, and carbon dioxide must go somewhere. Water must be protected, temperature must be controlled, air circulation must continue, waste must be handled,
Communication must function if cooperation is to extend beyond one sealed room. If a shelter houses many people, psychology becomes part of engineering. Fear, crowding, and scarcity begin working as strongly as valves and tanks. Survival after the first minutes would therefore be less like being saved and more like entering a second, quieter emergency. This is why cities would stop in minutes, but not end in minutes. Their visible life would crash immediately, yet their hidden systems would continue failing in layers. Elevators might freeze, where power and control persist briefly, then fail. Backup generators that require air intake would reveal their dependence. Water systems would behave unpredictably as pressure relationships changed. Communications could continue in some wired forms longer than human responders could use them effectively. Data would still pulse through buried cables. Cameras might still record empty streets. Doors might remain electronically locked over rooms where nobody could open them. The city would pass from human activity into mechanical afterlife, a ghost phase in which systems continued just long enough to expose how little systems matter without breath and attention behind them. Hospitals, which seem like the final refuge in a crisis, would illustrate the tragedy with special clarity. In most emergencies, people run toward medicine because medicine has time to intervene. Here, time would be the missing resource from the first second. Ventilators require power and breathable gas. Oxygen tanks are finite. Emergency rooms depend on doors opening, staff thinking clearly, elevators moving, communication flowing, and patients arriving alive enough to treat. Some sealed intensive care units might preserve life briefly for the people already inside them. Certain operating rooms or specialized chambers might become accidental shelters, but the hospital as a whole is not an independent planet. It is a sophisticated arrangement built inside a larger atmosphere. Take that larger atmosphere away, and even the best medicine on Earth meets the oldest limit of all. No blood remains useful for long if no oxygen enters the lungs. Underground spaces would tempt the imagination as well. Tunnels feel protected. Basements feel hidden. Subways and mines seem closer to the interior of the planet than to the sky. Yet depth alone is not enough. A cave is not automatically a life support system, and a tunnel is not automatically sealed. Most underground networks still breathe with the surface. Air shafts, station entrances, ventilation systems, service corridors, and pressure relationships link them to the world above. In some places, those same connections would become deadly pathways through which interior air was lost. In a few fortunate compartments, especially where heavy doors and technical isolation already existed, people might gain a small interval of survivable conditions. But the comforting idea that one could simply run underground and wait it out belongs to storms and war. This would be a disaster of environment itself. Unless a space could hold pressure, underground would mean hidden, not safe. Animals would respond according to the same brutal logic, though without the human capacity to understand what had changed. A flock of birds crossing the morning would not have time to become a symbol. Flight itself depends on the air they cut through. Dogs in yards, livestock in fields, fish near the surface, insects moving through gardens, all would face versions of the same sudden incompatibility. Many species would perish before any larger ecological chain reaction had time to unfold. This is one reason the first exposed phase of the event would feel so unnaturally empty to anyone who survived within a shelter. The silence would not be only human silence. It would be the absence of everything that usually confirms the presence of life. Wings, calls, rustling, barking, movement in the leaves, small ambient signs that a biosphere is operating around
you. Communication, one of humanity's proudest strengths, would also fracture in revealing ways. Wireless signals do not depend on breathable air in the simple way voices do, and some networks could continue functioning for a time if power and equipment remained intact. Text could still move through cables. A sealed refuge might receive data from other sealed refuges. But information is not rescue by itself. A message saying that the atmosphere is gone does not create air. A map of nearby shelters does not help someone already losing consciousness in the street. Even inside surviving habitats, the emotional effect of communication would be strange. People might know that others were alive hundreds of kilometers away and still feel more isolated than any generation before them, because between those pockets of life stretched not an inhabited landscape, but a planetary dead zone. There is also a deeper reason the first surviving groups would have to think differently from ordinary disaster survivors. In most crises, the strategic goal is restoration. You endure the storm until it passes. You conserve resources until roads reopen. But if Earth truly lost its atmosphere, there would be no expectation of the old outside returning on its own in hours or days. This would not be a passing event layered over a stable world. It would be the removal of the stable world. That fact would change the psychology of every decision made inside a pressurized shelter. Every liter of oxygen, every battery cycle, every sealed hatch, every argument over space, every medical choice, every attempt to contact others would take place under the shadow of a single understanding. The shelter is not a waiting room. It is the only piece of Earth left in reach. For that reason, the most valuable people in those early refuges would not necessarily be the strongest or the most authoritative in ordinary life. Value would shift toward those who understood systems: engineers, divers, pressure specialists, mechanics, doctors familiar with respiration, and anyone able to remain calm while solving physical problems would suddenly become custodians of time itself. This would not make the crisis noble. It would only reveal that survival in an airless world is inseparable from knowledge. When nature stops supporting life for free, every extra minute must be manufactured. And even then, that knowledge would buy extension, not victory. Air would have to be measured, circulated, cleaned, and guarded. Every leak would become a threat. Every door would become a border. Every routine task would carry the pressure of knowing that outside now meant pure exposure. And because so much of civilization is designed for continuity, the first hours would likely produce scenes of terrible contradiction. Traffic lights changing over deserted intersections, automated voices speaking into dead terminals, security cameras watching vacant lobbies, digital billboards still shining over streets where no pedestrian can look up, refrigeration humming in sealed back rooms while silence reigns outside, a greenhouse climate control system fighting bravely inside a building whose structure can no longer hold the larger world back. These details matter because they reveal something subtle and moving about technological society. Many of its systems are built to resist interruption, yet all of them still assume the primacy of the human body. The atmosphere disappears, and the machines learn, in their blind way, what we should have known all along. For those who remained conscious just long enough to try for a sealed refuge, decision would become a race against biology. The brain, under oxygen deprivation, is not an ideal strategist. Fine judgment deteriorates quickly. Motor control becomes unreliable. Vision may narrow. Panic can crowd out memory.
Even if you knew, in principle, that the best hope lay in pressure, seals, and stored air, could you act on that knowledge while the body was shutting down? Could you choose the right door instead of the nearest one? Could you operate equipment precisely enough? Could you avoid the instinct to waste your final useful seconds shouting? This is another reason why the disappearance of atmosphere would be so devastating. It would demand a kind of rapid technical clarity at exactly the moment when clarity is evaporating. And still, some would make it. Not many in the broad picture of the surface world, but enough to carry the human story a little.
Further, a team already inside a submarine beneath the sea, workers in a pressure-controlled facility, researchers in a sealed chamber, perhaps small groups in hardened shelters designed for chemical or radiological isolation, if those shelters could maintain pressure against the new outside. Their survival would not be dramatic in the cinematic sense. It would begin with gauges, seals, masks, valves, compressed gases, and controlled breathing. It would begin with checklists. It would begin with the oldest human hope of all, translated into technical form. Close the door. Keep the danger out. Keep the life in. Inside such places, time would briefly return. Not the luxurious time of ordinary life, but the precious time of the reprieved. Hearts would still race. Lungs would still move in useful air. People could speak and be heard. They could look at each other and understand that the world beyond the walls had become impossible. In that realization lies another primal fear, quieter than suffocation, and in some ways deeper. It is the fear of the broken threshold. Human beings can endure much while believing that outside remains part of the same world. Snow, war, storm, plague, flood, and darkness all allow the comforting thought that beyond the door there is still a landscape governed by familiar rules. In this case, beyond the door would no longer be weather or wilderness. It would be planetary exterior. That distinction would change language itself. Words like outside, window, road, and sky would begin to feel archaic, as if borrowed from a previous age. Inside a surviving habitat, you would not be sheltering from a temporary danger. You would be living inside a pressure vessel surrounded by an uninhabitable planetary surface. The city beyond might still be visible. Mountains would still stand. Rivers might still trace their paths, but the relationship would have changed. The earth you evolved to walk on would now resemble a place visited only by suited expeditions, if visited at all. The ordinary act of opening a door would become equivalent to stepping into vacuum. And it is here, in that newly drawn line between enclosed life and exposed planet, that the emotional meaning of the event broadens. At first, the story is about the body's emergency. Then it becomes a story about habitat. Very quickly after that, it becomes a story about scale. Because once a handful of survivors stabilizes their breathing and secures their pressure, the next realization arrives. Even if a few human beings remain alive, the world that made them possible is collapsing around them. Their refuge does not mean Earth has survived as a living surface world. It means they have preserved a tiny, local imitation of Earth for a little longer. This is why the first minutes are so important in understanding the whole scenario. They are not just a burst of crisis at the beginning of a larger tale. They reveal the core truth of the entire event. The atmosphere is not decorative. It is not a soft extra laid over rock and ocean. It is the active interface between space and life. It gives the lungs something to use, the ears something to hear through, the eyes a sky to interpret.
flames a chance to burn, engines something to exploit, weather something to become, and shelter a meaningful outside to shelter against. Remove it, and every surface habit of Earth begins to unwind from the same invisible center. The more one sits with this, the stranger ordinary life begins to seem. Every conversation on a sidewalk, every child chasing a ball, every train arriving under a gray sky, every field in summer, every gull above a harbor, every dog barking down an alley, every pilot lifting from a runway, every candle burning in a kitchen, every distant thunderstorm rolling sound across a valley, all of it is the atmosphere in action. We usually treat air as empty background. In truth, it is a vast living medium full of consequence. It presses, filters, carries, moderates, nourishes, and connects. It is so constant that we mistake it for absence. Only by imagining its removal do we see how much of Earth's personality resides in what cannot be seen. And even that is only the beginning. Because after the lungs fail, after the voices vanish, after the sky goes black and the cities stop, the planet does not simply freeze in place like a paused image. The loss of atmosphere sets larger processes into motion. Weather ceases because there is no air left to move. Fire dies
because oxygen no longer surrounds fuel. The oceans begin to respond to the new pressure regime. The surface world starts to drift away from the conditions under which forests, rivers, clouds, and coastlines learned their present shapes. Human survival, where it continues at all, retreats into bubbles of artificial Earth. Outside those bubbles, the planet begins its transformation into something bare, severe, and almost unrecognizable. And to understand that transformation, we have to keep moving outward, from the failing body to the changing world, and watch how Earth itself starts to lose the qualities that once made it feel like home. Beyond those walls, Earth would begin to lose one of its oldest habits. It would stop behaving like a world wrapped in air and start behaving like exposed matter under space itself. The change would not announce itself with a single grand explosion or a theatrical tearing of the sky. It would unfold through the failure of familiar balances, one after another, until the surface no longer felt like the setting of human history, but like a place that had been stripped back to a harsher physical truth. Mountains, oceans, deserts, forests, and cities would all remain where they were, yet the invisible medium that had connected them into one living surface would be gone, and without that medium, the planet would begin to feel strangely unfinished, as though some essential layer of reality had been erased. This is one of the most unsettling aspects of the scenario. If Earth lost its atmosphere, the continents would not vanish. The oceans would not instantly leave their basins. The ground beneath your feet would not collapse into a cosmic abyss. In silhouette, the planet would still resemble Earth, but its behavior would shift towards something closer to the Moon or Mars, where the surface is exposed directly to a far more severe set of rules. On our ordinary planet, the atmosphere is not only the source of breathable air, it is also the great mediator between sunlight and stone, between ocean and sky, between day and night, between local events and planetary circulation. Without that mediator, the surface is not simply deprived, it is redefined. To understand that transformation, it helps to think of Earth not as solid land beneath a gas layer, but as a coupled system in which rock, water, ice, life, and air are always exchanging energy and matter. The atmosphere moves heat from one region to another. It stores water vapor, carries clouds, drives storms, and moderates extremes.
It also slows the loss of heat from the surface through greenhouse gases, especially water vapor, carbon dioxide, and other trace gases that absorb and re-emit infrared radiation. This is not a detail added on top of climate. It is climate. Remove the atmosphere, and Earth does not merely lose blue skies and wind. It loses the mechanism that makes its surface temperatures relatively connected across space and time. The result would be a planet of sharper contrasts. In the absence of atmospheric scattering, the sun would pour energy more directly onto illuminated ground, while darkness would no longer be softened by air that had retained and redistributed heat. On the day side, exposed surfaces under direct sunlight could become intensely warm, depending on their color, composition, and angle to the sun. In shadow, and especially across the long arc of night, heat would radiate away far more freely to space. Our atmosphere acts like a blanket, but also like a circulating ocean. It does not simply trap warmth in one place, it moves it. Without it, there would be no winds carrying energy from equator toward pole, no moving masses of humid or dry air, no jet stream, no storm tracks, no cloud cover shifting sunlight from hour to hour. Heat would become far more local, and cold far more absolute. This does not mean every place on Earth would immediately become uniformly frozen or uniformly scorched. Reality would be more complex, and in some ways, more alien than that. Equatorial regions in full sunlight would continue receiving enormous solar energy, while night-facing regions and shaded terrains would cool with brutal efficiency. The difference between sunlit and dark conditions would widen dramatically. One of the reasons the moon experiences such severe temperature swings is that it lacks a substantial atmosphere to spread heat around or soften radiation losses. A bare Earth would not become identical to the moon
because Earth has oceans, a different rotation period, internal heat, and much greater thermal inertia in many materials. But the comparison is useful. It reminds us that once the atmosphere is gone, the surface begins living under rules that modern Earth largely conceals from us. Even the passage of a single day would feel transformed. Sunrise would no longer creep softly through a glowing horizon, with colors spreading ahead of the sun through layers of air. It would become more abrupt. The sun would appear against blackness, and illuminated surfaces would brighten without the familiar atmospheric prelude. Twilight, as we know it, depends on sunlight scattering through the upper atmosphere before the sun itself is visible from the ground. Without that atmosphere, dawn and dusk would lose much of their lingering character. There would still be geometry, angles, and changing shadows, but the emotional texture of morning and evening would be profoundly altered. Human beings have long associated the start and end of day with softness. In an airless world, daybreak would feel less like awakening and more like exposure. Then there is weather, one of the most ordinary miracles on Earth. We complain about it, predict it, ignore it, plan around it, photograph it, and build cultures around its patterns. Yet weather exists only because air moves, stores moisture, and changes temperature. The atmosphere is the weather. Remove it, and clouds cannot form in the familiar way. Rain cannot condense and fall through a moving sky. Snow cannot drift on winds that no longer exist. Hurricanes, monsoons, cyclones, fog banks, thunderstorms, sea breezes, and blizzards all disappear, not because they are defeated, but because the medium that allows them to exist is gone. The sky above Earth would stop acting like a living ceiling and become empty overhead space. This absence would change landscapes almost immediately at the level of perception.
and more slowly at the level of form. Many landscapes are visually defined by atmosphere. Mist softens valleys, humidity fades distant mountains into blue, dust in air catches sunset light, storm clouds cast moving shadows over plains. Without these effects, visibility, in the simple optical sense, could become astonishingly direct. Distant features would appear with unusual clarity when line of sight allowed it, yet the world would also become visually harsher, flatter in mood, and more severe in contrast. A canyon under black sky and hard sunlight would not resemble the same canyon beneath hazy daylight. A forest would no longer breathe moisture into the air above it. A coastline would no longer blur into sea spray and cloud. Earth's beauty would remain, but its softness would be gone. As the days passed, any surviving observers inside sealed habitats would begin to notice that the outside had ceased to produce motion of the familiar kind. Trees would not sway unless disturbed by impacts or structural failure. Tall grasses would not ripple. Smoke could not rise from exposed fires because exposed fires would not survive. Clouds would never gather over mountain ridges. There would be no weather fronts advancing across radar screens, no pressure systems crossing continents, no local forecasts to matter. Weather is one of the ways a planet expresses its metabolism. It is motion visible at a human scale. An airless Earth would lose that expression and take on the stillness of a body after breath has stopped. That stillness would reshape the oceans in particularly dramatic ways, because oceans and atmosphere are partners in almost every surface process involving water. Today, the sea gives vapor to the air, and the air returns water to the land. Waves are driven mostly by wind. Surface currents are influenced by atmospheric circulation, as well as deeper density differences. Ice forms or melts under the combined authority of temperature, salinity, sunlight, and moving air. The ocean is not separate from the sky. It is in conversation with it at every moment. Remove the atmosphere, and the conversation ends instantly. What follows is not a single, simple fate for all water, but a changing sequence of responses driven by pressure, temperature, and time. At first, the most surprising response would occur at the surface. Under ordinary atmospheric pressure, pure water at sea level boils at 100 degrees Celsius. Lower the pressure enough, and the boiling point falls dramatically. This is why water boils at
Lower temperatures high in the mountains push pressure all the way down toward vacuum, and liquid water can begin to boil at temperatures far below what most people associate with boiling. So, when Earth loses its atmosphere, surface water exposed to the new low-pressure environment would become unstable. It would not wait for heat in the ordinary culinary sense. It would respond to the sudden pressure drop by tending to vaporize. Lakes, puddles, wet soils, and the uppermost layers of the sea would all face this strange transition. But the ocean would not simply erupt into steam and vanish into space in a single day. It is far too large, and the physical process is more layered than that. Evaporation and boiling absorb energy. As water molecules escape into vapor, they carry heat away from the remaining liquid. This cooling effect matters enormously. In other words, the attempt of surface water to boil under low pressure would cool that very surface. With time, and especially without an atmosphere to hold heat near the ground, freezing would become increasingly important. The top of the ocean could begin moving through a bizarre phase in which instability, vapor loss, cooling, and eventual ice formation all interact. The sea would not behave like a pot on a stove.
It would behave like a planetary reservoir suddenly exposed to vacuum and then forced into a much colder, long-term balance. This is where time matters. In the very earliest phase, exposed liquid water would be prone to rapid vaporization at the surface. In the longer phase, the lack of atmospheric insulation and the steady radiation of heat into space would drive much of the surface toward colder conditions, especially away from constant sunlight and especially across the night side. Ice would begin to matter more and more. Over enough time, large portions of the oceans could freeze from the top down, creating a world where liquid water remained trapped beneath increasingly thick ice in many places, insulated from direct exposure by its own frozen skin. The exact pace would vary by location, depth, sunlight, geothermal influence, salinity, and the remaining heat stored in the ocean itself. But the larger point is clear. The sea would first lose its atmospheric partner, then its familiar surface behavior, and finally, much of its visible fluidity. Coastlines would become some of the strangest places on the planet. Today, they are dynamic edges shaped by tides, waves, wind, evaporation, rainfall, river input, and biological activity. In an airless world, many of those sculpting forces disappear or are drastically altered. Tides, because they are driven mainly by gravity from the moon and sun, would still exist. The ocean would continue to respond to those distant poles, but the visual drama of the shore would change because wind-driven waves would fade without air to push them. Surf zones would quiet. Beaches would lose the endless restlessness that makes them feel alive. If the surface waters began freezing, some shores would transition into eerie margins of ice, dark water, and exposed sediment under a black sky. The old relationship between sea and land would remain in outline, but not in spirit. Rivers present another subtle case. A river is not merely water moving downhill. It is part of a hydrological cycle that includes evaporation, clouds, rain, snowmelt, groundwater exchange, and atmospheric humidity. Remove the atmosphere, and no new rainfall arrives to replenish catchments. Some rivers would continue flowing briefly from existing momentum, stored upstream water, snowpacks, groundwater release, and gravitational descent, but their long-term continuity would be broken. Exposed surface flow would also face the same low-pressure instability as other water bodies. Over time, many rivers would dwindle, freeze, or vanish into more complex local states, depending on temperature and supply. Landscapes carved by flowing water would remain, but the active circulation of fresh water across continents would begin to fail. The hydrological cycle, one of Earth's most elegant long-term systems, would effectively stop. No atmosphere means no water vapor reservoir in the familiar sense, no cloud transport, no storms carrying moisture inland, no rainfall connecting sea to mountain to river to delta. Water would still exist on Earth, but it would no longer move through the planet in the breathing rhythm that has shaped climates, ecosystems, and civilizations.
This matters because life on land depends not simply on the existence of water, but on its circulation. A sealed tank of water in a bunker may preserve a handful of people. A functioning biosphere requires planetary cycling. Without atmosphere, water ceases to be a world-making participant and becomes a trapped resource, a local remnant, or a frozen archive. The death of weather and the transformation of water would also alter erosion. Much of the sculpture of Earth's surface today is done by moving water, shifting air, freeze-thaw cycles, and biological assistance.
Wind rounds dunes, lifts dust, and carves stone over time. Rain attacks rock chemically and physically. Rivers grind mountains into sediment. Roots break cracks wider. Ice expands in fractures and breaks cliffs apart. In the first phase after atmospheric loss, many of these familiar agents weaken or vanish. Landscapes would not stop changing entirely. Gravity, impacts, tectonics, and thermal stress would remain, but a great part of the slow surface conversation that turns rock into soil and soil into landscape would go quiet. The planet would begin to preserve certain forms rather than continually softening and renewing them. One of the first practical consequences for surviving human enclaves would be the loss of fire as an available outdoor tool. This may sound small compared to the loss of weather and oceans, but fire occupies a unique place in both survival and civilization. It is warmth, chemistry, cooking, sterilization, illumination, metallurgy, ritual, and psychological comfort. In ordinary life, a flame represents controlled energy. In an airless outside environment, exposed flames cannot continue because combustion requires an oxidizer. In carefully engineered systems, combustion could still occur if oxygen were supplied within controlled chambers, just as rockets carry oxidizer when they burn in space. But the old human relationship with open flame under the sky would end. No campfire would burn on the frozen plain. No signal fire would rise from a hill. No torch could be carried into the dark outdoors. One of our oldest technologies would be exiled indoors into sealed devices and managed atmospheres. The same is true, in a different way, for sound. Earlier, we imagined the shock of immediate silence in the first exposed moments. Over longer time, the absence of atmospheric sound would become one of the deepest changes in how Earth is experienced. Large parts of what we think of as landscape are soundscapes: surf against rocks, rain on roofs, wind in pines, thunder over open country, birds at dawn, insects in evening heat, distant traffic under city haze. Remove air, and those external sounds vanish. Survivors inside shelters could still hear one another, hear machinery, hear the hum of fans and pumps and recycled air systems, but the outside would remain visually present and acoustically dead. That mismatch would likely become one of the most emotionally difficult parts of life in refuge. The world would still be visible through thick windows or external cameras, yet it would no longer speak. If the airless Earth were viewed from orbit, it might first look almost serene. The continents would remain, the oceans would still gleam where liquid or frozen surfaces reflected sunlight, and clouds would be gone, revealing the whole hard geography of the planet with unusual clarity. But that apparent serenity would be misleading. What had been removed was not clutter. It was one of the main signs of planetary vitality. Clouds, storms, hazes, and moving weather systems are evidence that a planet is actively exchanging heat and water through an atmosphere. Their absence would make Earth resemble a quieter world, but quiet in the same sense that a stopped heart is quiet. Surviving human groups would have to learn this quickly, because their own continued existence would depend on replacing, at small scale, functions the planet once performed automatically. The air inside a refuge could not simply remain breathable because it started that way. Human metabolism would begin changing it at once. Oxygen would be consumed, carbon dioxide would rise, moisture would accumulate, heat would build in some areas and bleed from others. In a normal building, many of these changes are moderated by constant interaction with the outside atmosphere. In a sealed habitat, they become engineering tasks. Fans must circulate air to prevent pockets of stagnation. Carbon dioxide must
Be scrubbed chemically or biologically. Oxygen must come from stored tanks, electrolysis, chemical generation, or another reliable system. Pressure must be monitored because even a small leak, if persistent, becomes existential over time. This is why asking how long humans could last after atmospheric loss becomes less a question about toughness and more a question about systems. A very fit person in the open survives only briefly. A frail person inside a robust, pressurized habitat with power, water, and air management could outlast them by weeks, months, or longer, depending on supplies and maintenance. Survival ceases to reward physical adaptation to nature and begins rewarding successful substitution for nature. This is a profound shift. On ordinary Earth, even complex societies rely constantly on planetary services they did not build. Air circulation, climate moderation, water cycling, sunlight filtered into usable forms. In an airless world, any surviving human pocket becomes a miniature attempt to recreate those services artificially. The simplest refuges would be limited by stored resources. A chamber with compressed oxygen and water might preserve life for a short time, but unless carbon dioxide is removed and pressure maintained, the air would quickly become unusable. More advanced systems would need recycling. Spacecraft and submarines already offer some examples of how humans can survive inside closed or semi-closed environments. Carbon dioxide scrubbers, oxygen reserves, electrolysis of water, humidity control, thermal regulation, and strict resource accounting all become part of daily existence. But even these technologies, impressive as they are, remain delicate. They depend on energy, spare parts, technical knowledge, and disciplined operation. A habitat is not a magical bubble. It is a machine that must be kept alive while it keeps people alive. Water would become one of the central limiting factors, not because Earth had no water left, but because accessible, protected liquid water inside refuge would be precious. Outside sources would no longer be easily available. Collecting surface water in vacuum conditions from a hostile environment would require equipment, suits, and energy. If the oceans and lakes outside were entering phases of vapor loss, freezing, or surface instability, that challenge would only grow. Stored water could be recycled to some extent, as it is in spacecraft and some remote stations, but recycling is never effortless. Filtration systems clog, pumps fail, membranes age, waste treatment becomes inseparable from survival. In this way, an airless Earth would force human beings to confront a truth long hidden by abundance. Life depends not just on resources existing somewhere on the planet, but on them moving through systems we can actually use. Food would become an equally complex problem. In the first period, shelters would rely on stored calories. Canned food, dry rations, preserved grains, freezer stores if power remained, and emergency reserves would matter far more than fields outside. Agriculture in the long term would require controlled environments with pressure, water, lighting, nutrients, and gas management. Plants need carbon dioxide and water, but they also need temperature ranges, light cycles, and structural conditions compatible with growth. An airless Earth does not remove the possibility of growing plants inside habitats, but it makes agriculture entirely artificial for survivors. No open field remains, no rainfall assists, no pollinating wind moves. The oldest human act, sowing under the sky and waiting for season, would be over. The energy question would divide shelters into the temporary and the potentially enduring. A sealed refuge with no reliable power source would eventually fail,
even if it began with generous air and water. Pumps, lights, communications, environmental controls, medical equipment, and recycling systems all require energy. Solar power might remain useful in some places because the sun still shines, and without atmospheric scattering, the direct sunlight on exposed panels could be intense. But that same exposed environment would make maintenance difficult, and the day-night cycle would still interrupt generation unless storage systems were strong. Nuclear power, if safely available, would become extraordinarily valuable because it offers long-duration energy independent of weather. Ironically, the end of weather would remove some of the
variability solar planners once had to manage, but it would replace it with a harsher thermal and maintenance environment. Time, then, would become the true currency of post-atmosphere survival. Every shelter would effectively be asking the same question in a different accent. How many days of breathable pressure can we maintain? How many days of water can we recycle? How many days of power can we guarantee? How many failures can we absorb before one of them becomes final? Some habitats might endure for a short while and then fail because of a single leak or power loss. Others might last far longer through design, discipline, and fortunate circumstance. But none would be living in restoration. They would all be extending a local exception inside a planetary catastrophe. This would alter human relationships as much as physics alters the surface. In ordinary life, social conflict can often diffuse into space. A person can step outside, walk, drive away, cool off, seek privacy. In a sealed habitat, space becomes finite and pressure becomes collective. Every person present consumes air, water, and calories. Every decision affects the shared environment. Under such conditions, social harmony is not a luxury. It becomes infrastructure. Leadership matters, but so does trust. Technical knowledge matters, but so does emotional regulation. The atmosphere once gave humanity an almost infinite commons without asking permission. After its loss, every refuge would become a tiny negotiated society enclosed inside walls. The outside world, meanwhile, would continue drifting farther from human habitability. The exposed surface would not only lose weather and much of its liquid water behavior, it would also lose the ordinary operation of many technologies. Aircraft, as we noted before, depend on air for lift and control, but the implications go wider. Sound-based outdoor sensors become useless in the same way voices do. Many cooling systems designed for atmospheric conditions work poorly or differently. Mechanical materials expand and contract under more severe temperature swings. Lubricants, seals, and electronics exposed directly to vacuum and harsh radiation would face new stresses. Roads might still lie where they were built, but the traffic civilization that gave them meaning would be gone. Harbors would still indent the coasts, but ships designed for atmospheric weather and open-air cruise would have little role. Cities would remain as architectures without climate, infrastructures without biosphere. Even the idea of going outside would change from an ordinary action to an expeditionary event. If survivors possessed suits, pressure gear, and the means to cycle through airlocks, then the planet's surface might still be visited briefly for repair, salvage, observation, or retrieval. But a suited human on an airless Earth would not be walking in weather. They would be performing extraplanetary operations on their own world. Each outing would require preparation, oxygen budgeting, communication discipline, thermal planning, and return margins.
A broken seal, cracked visor, or failed regulator would not mean discomfort. It would mean exposure to the same lethal conditions that ended open life on the first day. Earth would no longer be home terrain. It would be mission terrain. This is one of the strangest philosophical consequences of the scenario. Home is usually defined not by affection alone, but by metabolic compatibility. A place is home when you can live there without machinery mediating every breath. By that standard, once the atmosphere is gone, the open earth ceases to be home, even for the species that evolved there. A sealed chamber becomes more terrestrial than the planet outside because it preserves the conditions under which terrestrial life is possible. The ground beneath the chamber may still be Earth, but the livable world has shrunk inward to the artificially maintained volume of air around the survivors. The comparison with other worlds in our solar system becomes unavoidable here. Mars, with its thin atmosphere, offers little pressure and no breathable air. The Moon offers essentially none. Space agencies design habitats, rovers, and life support systems for those environments because biology alone is not enough there. If Earth lost its atmosphere, the difference between living on Earth and living on another exposed planetary surface would narrow dramatically. Gravity would remain Earth's gravity. The
composition of the crust and oceans would remain Earth's, but the basic survival logic would become extraterrestrial. The psychological weight of that realization would be immense. Humanity would not have gone to another world. Another world would have arrived here. For the larger biosphere, this shift would be unforgiving. Most complex land life depends directly or indirectly on atmospheric oxygen, moderate pressure, water cycling, and temperatures softened by air. Plants depend on gas exchange, light, liquid water, and compatible thermal conditions. Animals depend on plants or on other animals that depend on plants. Microbial life is more flexible, and some forms of life in protected environments could persist much longer, especially underground or in deep subsurface niches where local chemical and thermal conditions remain suitable. But the visible, surface-level abundance that defines modern Earth would begin to collapse rapidly. Forests would not simply stand unchanged like museum exhibits. Their tissues would dry, freeze, and fail. Grasses would not ripple toward next season. The great visible skin of life that covers continents would begin withdrawing from the surface. Yet the timing of these changes would vary, and that variation matters because it preserves a sense of unfolding rather than instant universal death. Some seeds can endure severe dormancy. Some microbes can survive extraordinary extremes. Some deep marine or subterranean organisms inhabit environments already buffered from the surface. Thick ice, deep water, rock, and sealed sediments all offer local protections that the atmosphere once provided more broadly. So the disappearance of atmosphere would not erase all life in a single uniform stroke. Instead, it would drive a brutal sorting process. Open surface life would fail first and most visibly. Protected, insulated, chemically unusual, or deeply buried life might linger. This nuance is important because it prevents the scenario from becoming cartoonishly simple. Earth would not become absolutely sterile overnight, but it would stop being a world whose surface naturally supports rich, exposed life. Among the many habits that would die with the atmosphere, perhaps none is more quietly heartbreaking than the habit of weather memory. Human cultures are full of atmospheric recollection. The smell before rain, the heat of noon held in stone after sunset,
the sound of distant thunder, the first cold morning of autumn, the strange electric quiet before snow. These are not sentimental extras added to life. They are how a species embedded in atmosphere experiences time. If the atmosphere vanished, memory itself would become painful in a new way. Survivors in refuges would remember not only people and places, but textures of weather that could never return outside. To remember wind would be to remember the old Earth. This is why the scientific seriousness of the scenario does not diminish its emotional power. On the contrary, the more carefully we follow the real physics, the more profound the loss becomes. The disappearance of atmosphere removes a long chain of ordinary miracles at once. It reveals that the world we call normal is not simply rock and water beneath sunlight, but rock and water interacting through gas, pressure, circulation, and climate. What appears empty above us is actually a vast operating system. When that operating system fails, the exposed surface does not merely become dangerous, it loses its identity. A useful way to think about long-term human survival in this world is to compare it to life in places where atmosphere is already absent or insufficient. Orbiting stations, deep submarines, isolated polar facilities, and planned habitats for the Moon or Mars. In all of them, survival depends on a chain of successful replacements. Air is stored or regenerated. Carbon dioxide is removed before it reaches dangerous levels. Water is recovered from waste and humidity. Heat is balanced. Small failures are noticed early because unattended small failures become large ones. On an ordinary planet, nature constantly hides those maintenance burdens from us. In an airless world, nothing hides them. A blocked filter, a faulty seal, a worn pump, a valve that does not close completely, all become visible as threats because there is no wider atmosphere left to forgive mistakes. This is also where carbon dioxide becomes as important as oxygen. People often imagine suffocation simply as the absence
Of oxygen. But enclosed life is equally a problem of waste gas accumulation. Even if a habitat begins with ample breathable air, every person inside is steadily changing that air with each breath. Carbon dioxide rising too high brings headache, confusion, air hunger, and eventually severe danger. So the real duration of a refuge is determined by more than tank size. It depends on active atmospheric management. The habitat must not merely contain air. It must function like a tiny artificial atmosphere, continuously corrected against the chemistry of living bodies. For some groups, that effort might buy only hours. For others, with disciplined rationing, technical skill, and robust equipment, it could buy much longer. But longer survival would come at a psychological price. Outside the walls, there would be no hint of seasonal return, no promise of spring rain or warmer winds, no evidence that the planet was healing itself. The old background faith that tomorrow would resemble Earth would be gone. People would be alive inside fragments of continuity, while the larger continuity of the surface had been broken. And that awareness would matter, because human beings do not live by mechanics alone. They also live by expectation. Once the atmosphere is lost, expectation narrows. Survival remains possible in pockets, but belonging does not. The open world can still be seen, measured, crossed in suits, and perhaps used in small ways. It simply can no longer welcome. That is why this stage of the story feels so uncanny. Nothing has disappeared in the simple sense. The planet is still there, enormous and visible, yet the qualities that once turned visibility into life, movement, weather, and
comfort have withdrawn. Earth has not been destroyed. It has been emptied of one of its deepest permissions for us. And beyond the immediate tactical questions lies the deeper planetary one. Even if some humans last months or years inside controlled habitats, what kind of Earth are they actually inheriting? A world without weather, a world where the oceans are changing state, a world where the surface swings more sharply between heat and cold, a world where open fire, open breathing, open water cycles, and open ecosystems are gone. That is not simply a damaged civilization. It is a new planetary condition. The survivors would not just be waiting for rescue. They would be learning the rules of a stripped Earth. The farther we follow those rules, the more the planet seems to move away from us. The first silence was personal. The next silence was meteorological. Soon it becomes biological and geological in mood, as if Earth were slowly shedding the traits that made it feel intimate to human senses. And when we continue that journey outward, into the cold, into the freezing surface, into the fate of plants, animals, and oceans under long exposure, the real scale of the transformation begins to show. Because losing the atmosphere is not only the end of breath, it is the beginning of a much slower unmaking, in which the surface of Earth itself starts to drift toward the still severe character of a world that no longer knows how to hold life in the open. Now, the change would begin to settle into duration. The first shock belonged to seconds and minutes, to lungs, pressure, silence, and the collapse of ordinary motion. But after that first terrible phase, the planet would enter something colder, slower, and in its own way, more profound. Earth would not simply remain exposed. It would begin to reorganize under exposure. Heat that once lingered near the ground would slip away more easily into space. Shadows would grow harsher in meaning. Night would become a deeper physical event, not merely the absence of sunlight, but the withdrawal of one of the few remaining sources of surface warmth. The familiar surface world, once buffered by a moving ocean of air, would begin to harden into a place of extremes. This would not happen with perfect uniformity. Earth is too large, too varied in terrain, water content, albedo, latitude, and thermal inertia for any single description to fit every place at once. Still, the broad direction is clear. Without the atmosphere to trap and redistribute heat, the surface loses one of its greatest protections against severe temperature swings. Sunlit ground can become intensely warm because there is no air above it to scatter light broadly, and no wind to carry heat away in familiar ways. But once the light is gone, or once a
surface falls into shadow, that same place can cool with startling efficiency. A world without atmosphere is not merely cold, it is thermally unstable in a way that modern Earth rarely allows us to feel. The oceans, enormous as they are, would delay some of this transformation because water stores heat so well. Vast bodies of water do not change temperature as quickly as dry rock or thin soil. That is one reason coastal climates on present Earth are often milder than inland ones. But here again, the old balance would no longer hold. The sea surface, exposed first to low pressure and then to relentless radiative loss, would increasingly become a skin of transition. In some places, especially where darkness lingers and energy is not continuously supplied by direct sunlight, ice would begin to spread. At first, it might appear in patches, films, brittle margins, and complex frozen crusts that trap darker water beneath. Then,
Over longer stretches of time, the frozen lid could thicken. A planet once defined by moving blue surfaces would slowly present more white, more gray, more dark glass under starlight. The image is haunting because ice changes more than temperature. It changes sound, motion, and expectation. An ocean covered in ice no longer behaves like a breathing body under the wind. It becomes a sealed plain, a boundary rather than an exchange. On modern Earth, sea ice already alters ecosystems, currents, light penetration, and climate feedbacks. In an airless Earth, where freezing could advance without the moderating conversation of atmosphere, the symbolic meaning would be even greater. The liquid planet would be withdrawing from the surface. Water might still exist in abundance below ice and in deeper reservoirs, but to the eye, and to any surviving human expedition in a suit, the world would look increasingly locked. Land would respond according to its own materials. Deserts, forests, cities, fields, mountain slopes, and coastlines would all begin to acquire the stillness of a place no longer sharing heat with moving air. Stone, warmed by direct sunlight, would radiate hard. Metal structures would pass through severe temperature cycles. Glass could crack. Asphalt would lose the thermal environment for which it was designed. The great human surfaces of roads, rooftops, runways, bridges, pipelines, and power lines would remain for a time, yet they would no longer live inside the climate they were built for. Expansion and contraction would stress them. Materials age differently in vacuum and under more severe radiation. Paint fades, polymers grow brittle, lubricants fail. The city, which once seemed a triumphant extension of human will, would begin to weather under a new set of forces that are, in truth, less like weather than exposure. Snow, as we know it, would be gone, because snowfall depends on clouds and atmosphere, yet the world could still become more frozen. That distinction matters. There would be no romantic storm laying a soft blanket over streets, no flakes drifting through lamplight, no wind-carved drifts against doors. Instead, there would be freezing without snow, frost without moisture moving through air, cold without weather. It would be a more severe kind of winter, one stripped of all the habits by which winter announces itself. The surface would not be wrapped, it would be emptied and chilled. For human memory, this would be one of the strangest wounds. People know how to imagine cold climates, polar expeditions, ice ages, blizzards, and glacial valleys. But those belong to an atmospheric Earth. This new cold would belong to a different category altogether. Life on land would meet it badly. Plants, in particular, would reveal how dependent the visible world is on the marriage between sunlight, water, air, and moderate surface conditions. A plant is not simply green matter rooted in soil. It is a gas exchange system, a water transport system, a light harvesting structure, and a chemistry of astonishing delicacy sustained across tissues. Leaves take in carbon dioxide and release oxygen through stomata, tiny openings that also govern water loss. Roots draw up liquid water. Cells depend on pressures, membranes, and temperatures that must stay within workable ranges. Without atmosphere, plants do not just lose one ingredient. They lose the entire framework that makes ordinary photosynthetic life on the surface possible. Some protected seeds could persist in dormancy for long periods. Some spores,
Pollen grains, and microbial forms are already famous for endurance. But the living green surfaces of Earth would begin to fail. Forest canopies would no longer transpire moisture into the air. There would be no air to receive it. Fields would not continue their quiet photosynthetic labor under black skies and hard sunlight. Mosses, ferns, grasses, crops, trees, vines, wetland reeds, alpine flowers, desert shrubs, all the immense variety of plant form would face the same deeper truth. The surface world had ceased to be a place where ordinary metabolism could continue in the open. The first visible changes might be subtle in some species, because tissues can hold water and structural integrity briefly. Then discoloration, collapse, desiccation, freezing damage, and the breakdown of circulation within the plant body would follow. This would carry emotional weight beyond botany. Plants are the visible patience of the earth. They give the planet its softness, its textures of season, its shades of green, gold, brown, and crimson. They catch light and turn it into food, shade, timber, fragrance, shelter, and atmosphere itself. To imagine their loss is to imagine the loss of one of the main reasons Earth does not look like another dead world. A city without people can still feel alive if trees move above its sidewalks and weeds rise through its cracks. Remove the possibility of living vegetation, and the city becomes not abandoned, but geologically stranded, as though it had already passed into another epoch. Animals would follow, each according to their physiology, their dependence on surface oxygen, and the protection available in their habitats. Large land animals would have almost no chance in the open. Birds, already betrayed by the disappearance of air as a medium for flight, would vanish quickly. Insects, despite their hardiness in many conditions, still depend on environmental gas exchange and on ecological systems that would be collapsing around them. Reptiles, amphibians, and mammals all carry their own versions of atmospheric dependence, whether through lungs, skin, or the complex food webs that sustain them. Aquatic animals would be influenced not only by the atmospheric loss above, but by the changing state of the waters they inhabit. Surface marine life would face some of the earliest and harshest transitions. Deeper marine life might endure longer, where liquid water, pressure, and chemical gradients remained relatively stable beneath forming ice. It is worth lingering here, because extinction in such a world would not be a single synchronized gesture. It would be layered. Creatures exposed directly at the surface would disappear first. Those with access to protected environments, stored oxygen, dormant states, deep burrows, subsurface water, or specialized chemistry might last longer. Some microbes in rocks, deep sediments, hydrothermal systems, or subterranean aquifers could persist far beyond the collapse of visible surface ecosystems. Extremophiles already teach us that life can occupy niches once thought impossible, but that nuance should not soften the larger picture. The biosphere recognizable to human senses would be ending. Forest birds, grazing herds, pollinating insects, coral reefs in shallow sunlit seas, river fish in open currents, all the exposed, richly interactive forms of life that make Earth feel biologically crowded would fade from the surface. As they faded, the planet's color palette would change. This is more than an artistic thought. Earth's appearance from orbit and from the ground depends heavily on life. Vegetation changes reflectivity. Forests and grasslands absorb and scatter light differently from bare rock or ice. Algal blooms tint shallow waters. Soil darkens with moisture and organic content. Seasonal plant growth creates entire continental pulses of color visible from space. Remove this living skin,
and the world shifts. Brown, gray, white, black, and the muted mineral tones of exposed geology would replace much of the green signature that has long marked Earth as a living planet. Even before absolute sterilization, Earth would begin to look less inhabited simply because the biological pigments that once announced metabolism would be gone or hidden. There would also be a slow unraveling of the atmosphere's old legacy in the soils. Soil is not just ground-up rock. It is a living mixture of minerals, organic matter, water, gases, fungi, roots, microbes, insects, and
countless tiny interactions. On ordinary Earth, soils breathe. They exchange moisture with the air. They support decomposition. They change under rain, drought, freezing, heat, and seasons. In an airless world, that upper layer of fertility would stop behaving like living soil and start behaving more like exposed sediment. Organic matter would no longer enter decomposition pathways in the same familiar way, where oxygen, water cycling, and microbial communities had collapsed. Moisture near the surface would be lost or frozen. Root systems would die. The living conversation beneath forests and fields would go quiet. What had once been one of the most complex interfaces on the planet would become still, simplified, and mineral. For surviving humans, this would have practical consequences beyond grief. Any long-term hope of rebuilding something like ordinary life on the surface would be blocked not only by the absence of breathable air, but by the destruction of the open biological foundation. You could not simply wait for the first emergency to pass, step outside in a suit, and begin planting fields under black skies. Open agriculture would remain impossible. Pollinators would be gone. Rain would not come. Soil would no longer behave like agricultural soil. Water would be trapped, unstable, frozen, or accessible only through equipment. Even if a community had preserved seeds and knowledge, cultivation would have to occur inside controlled environments, with artificial pressure, water management, and light or filtered sunlight. In that sense, the end of atmosphere would also be the end of open farming, which means the end of the oldest enduring contract between humanity and land. The longer one follows these consequences, the clearer it becomes that Earth's habitability is not located in any single feature, not in water alone, not in the sun alone, not in rock chemistry alone. It emerges from relationships: air with pressure, water with circulation, sunlight with moderation, land with weathering, life with climate. That is why this hypothetical is so revealing. It strips away one major partner from the system and shows how many other relationships collapse with it. A living planet is not simply a checklist of ingredients. It is a choreography. Remove the atmosphere, and the dance stops almost everywhere visible. There would be another consequence, quieter than the death of weather and slower than the failure of exposed life, yet deeply important for the planet's appearance and for any future observer trying to understand what had happened. Earth would begin to lose the small visual signs that usually tell us a surface is active. On the present planet, activity is everywhere, even when nothing dramatic is occurring. A cloud shadow crosses a hillside, dust rises behind a vehicle, waves wrinkle a bay, leaves tremble in a light breeze too faint to feel indoors. Seasonal moisture darkens one patch of ground while another dries. In an airless world, many of these tiny signals disappear. The world does not merely become silent in the grand sense, it becomes visibly still at the human scale. That stillness would make time itself feel different. Days would pass, but the surface would seem less eventful,
as though the world had withdrawn from the small, expressive gestures by which it once showed that it was alive. Ice growing over the oceans would contribute to that impression in a powerful way. The sea has always been one of Earth's great storytellers. It reflects the sky, responds to storms, breaks into surf, rolls under moonlight, and changes mood from hour to hour. It is one of the main reasons our planet feels dynamic, even when continents appear stable. If the atmosphere were gone, and thickening ice began to spread over broader areas of the surface ocean, then a great share of that visible motion would be hidden. Beneath the ice, liquid water might continue moving for a very long time, carrying heat, salt, and chemistry through the darkness. But from above, many regions would appear sealed, simplified, and emotionally remote. A future traveler looking across a frozen sea under a black sky would not be looking at the end of water, but at water concealed from ordinary sight. This distinction matters because concealed systems can continue long after visible systems disappear. Earth's oceans would not instantly become solid all the way down. Water is too deep, too massive, and too thermally complex for that. Ice at the
Surface can insulate what lies below, slowing the loss of heat from deeper liquid layers. On our real planet, subglacial lakes, deep ocean basins, and waters beneath polar ice shelves show how liquid reservoirs can persist beneath frozen coverings. An airless Earth could preserve forms of hidden liquidity in similar ways, especially where geothermal heat, salinity, pressure, and depth work together. That does not rescue the open biosphere, but it does make the planet more subtle than a simple image of total freezing suggests. The outside world would be dead to ordinary walking life. Yet, beneath certain surfaces, a quieter geography of persistence could remain. Some of that persistence could matter biologically. The deepest lesson from extremophile research is not that life can thrive anywhere, but that life can endure in places far less forgiving than surface intuition once allowed. Microbial communities have been found deep below ground, around hydrothermal vents, within ancient rock fractures, in highly saline waters, and in environments cut off from sunlight. They remind us that surface habitability and total habitability are not the same thing. If Earth lost its atmosphere, the grand open page of forests, grasslands, reefs, and rivers would close, but a few footnotes of life might continue in darkness, warmth, chemistry, and pressure beneath the ruined surface. Those footnotes would be small compared with the old biosphere, yet they would matter philosophically. They would mean that the planet had not become lifeless everywhere, only estranged from the kind of life that once filled its horizons. Human beings inside long-lasting habitats would eventually have to think like deep-time creatures as well. In the first days or weeks, survival would be operational. Air, water, power, repair, medical care, sleep. Later, if any communities stabilized, a different question would emerge. What kind of future can be imagined inside a world that no longer offers an open outside? That question goes beyond engineering. It touches education, memory, reproduction, law, meaning, and time. A settlement that expects rescue behaves one way. A settlement that begins to suspect there will be no return to ordinary Earth behaves another. The old cultural calendar of weather, harvest, migration, and season would become historical rather than practical.
New calendars might follow power cycles, maintenance intervals, light schedules, and oxygen reserves instead of spring and winter. In a strange reversal, civilization would become more artificial at the exact moment it became more honest about its dependence on natural systems. The planet's surface, seen over years, would therefore acquire a double character. On the one hand, it would look more barren, more mineral, more exposed, more like the austere worlds that circle other suns. On the other hand, it would continue hiding pockets of warmth, liquid, chemistry, and perhaps even thought beneath that severe exterior. A bare world from a distance, a layered one up close. That contrast is worth holding in mind because it prevents the imagined Earth from becoming a simple, dead postcard. Its drama lies not only in what is lost, but in what is forced inward. Atmosphere gone, weather gone, open ecosystems gone, and yet, under ice, under rock, inside chambers, something remains, small and difficult and stubborn, refusing complete disappearance. Even the traces of the old atmosphere would linger for a while in the records of instruments and in the chemistry of trapped places, air sealed in tanks, bubbles frozen in ancient ice, gases dissolved in deep waters, archives of weather data, satellite images of vanished storms, all would become evidence that the planet had once worn a different face. Future survivors, if they had the calm and the time to study these remnants, would not be inventing the memory of blue skies. They would be reading a vanished climate the way geologists read vanished seas in stone. And perhaps that too would deepen the strangeness. The lost atmosphere would not be mythical. It would be measurable, documented, preserved in samples and numbers, waiting in rooms for minds still alive enough to understand what had been taken from the world and what had once held it together. And still, in the deep time sense, the story does not simply end with a frozen, silent Earth. Planets continue. They cool, crack, outgas, circulate heat from inside, suffer impacts, build minerals, and change
through geology, even when life has retreated. Earth's interior would not vanish because its atmosphere did. Radioactive decay would still warm the mantle and core. Tectonic motions would not halt in a single instant. Volcanoes, where and when they occurred, could still release gases from the interior. Subsurface water could still interact with rock. Deep hydrothermal systems might continue for very long periods, preserving some niches and some chemistry. The surface would be transformed, but the planet beneath the surface would remain a dynamic body. This raises one of the most haunting questions in the scenario. Could Earth ever regain an atmosphere? Over very long spans, the answer is not simply no. Planetary atmospheres can be supplied and modified by volcanic outgassing, impacts, chemical reactions, and exchanges with interior reservoirs. On early Earth, the atmosphere was not a static gift handed down once and never altered again. It evolved through immense spans of time and through interaction with geology and life. If an atmosphere were somehow stripped away, future outgassing from volcanoes and tectonic systems could begin building gases above the surface again. But the key phrase is future outgassing, and the key scale is geologic time. Such a recovery would not occur on the timescale of a human emergency, a human civilization, or likely even a human species as we know it. That distinction matters because it draws a line between planetary possibility and human relevance. Yes, Earth is not a simple inert sphere. It is capable,
over long intervals of releasing gases from within. But a thin, early secondary atmosphere produced that way would not instantly recreate the lost world. It might begin as something harsh, chemically different, sparse, and unstable. Without the existing biosphere to shape oxygen levels and carbon cycling, without oceans behaving normally at the surface, without living forests and plankton and soils participating, a new atmospheric history would not simply rewind to the old one. It would begin a different chapter, a chapter possibly measured in millions of years, a chapter for another planet, even if it used the same rock. This is where the thought experiment turns from catastrophe into perspective. If Earth lost its atmosphere tomorrow, the tragedy would be immediate for living beings. But in the deeper sense, it would also reveal how contingent our world really is. Human beings often treat the planet as stage scenery, stable ground, blue sky, dependable weather, water in motion, seasons returning on schedule. In reality, all of this rests on balances that can be described scientifically, but rarely felt emotionally until one imagines their loss. The atmosphere is thin. The habitable skin of Earth is thin. The margin between a living world and a dead one is, in planetary terms, astonishingly delicate. That delicacy does not make Earth weak. It makes Earth specific. Many worlds exist. Far fewer are worlds where liquid water can persist broadly at the surface, where sunlight arrives in usable form, where chemistry, pressure, and climate align for open ecosystems, where one species can stand outside with no machinery and breathe. This is why asking what would happen if Earth lost its atmosphere is not only a story about destruction, it is also an indirect way of asking what the atmosphere is doing for us every second now, while we sleep, walk, argue, eat, travel, and forget that it exists. The scenario frightens precisely because it makes the invisible visible through absence. Seen from far enough away, an airless Earth would still be beautiful. There would still be shining limbs of light on the curve of the planet. There would still be continents with their unforgettable shapes. Mountain chains would still cast long shadows. Great impact scars and volcanic provinces would still mark the crust. The moon would still rise over the same horizon from the same orbital partnership. The sun would still illuminate oceans, ice, and bare terrain. Beauty would survive, because beauty is not only life. It is also form, light, scale, and relation. Yet it would be a colder beauty, less intimate, a beauty one admires from glass and distance, not one that welcomes the body into itself. That kind of beauty already exists elsewhere in the solar system. The moon is beautiful. Mars is beautiful. The icy moons of the outer planets are beautiful. But their beauty belongs to worlds where the open surface is not.
For us, if Earth lost its atmosphere, our own planet would join that category. The emotional force of the idea lies there. We usually draw a firm line between Earth and the rest, between the place of home and the places of exploration. Remove the atmosphere, and that line blurs. Earth keeps its familiar geography, but loses its immediate hospitality. It becomes recognizable and unreachable at once. For any remaining human communities, this would slowly change memory itself. People raised entirely within sealed habitats would know Earth first through mediated experience, through windows, cameras, old recordings, stories, preserved books, and the testimony of the last generation who had once stood in rain or felt unfiltered wind. To them, grass moving in a summer field might sound as improbable as a myth. Thunderstorms would belong to archived footage. Fog would be something described with reverence, like a forgotten kind of softness.
The old world would continue inside language long after it had ceased outside. Children might learn the word breeze before they ever encountered a volume of free-moving air large enough to deserve the word. In that sense, the atmosphere would remain culturally present after it had vanished physically, as memory, longing, and inherited astonishment. There is something almost geological about that process. Sediments preserve traces of vanished oceans, vanished forests, vanished extinctions. Minds would do the same for vanished weather. Human culture would become a fossil bed of atmospheric life. Poems, songs, prayers, recipes, architecture, myths of spring, habits of travel, even simple metaphors would carry evidence of a lost medium. Consider how many phrases in every language depend on sky and air. A cloud over the mood, a storm brewing, clear air, open air, under the weather, a breath of relief, a windfall, the calm before the storm. Remove the atmosphere, and language itself becomes a museum of former conditions. And perhaps that is one of the deepest reasons this scenario feels more than merely technical. The atmosphere is not just part of environmental science, it is part of consciousness. It shapes the sensory grammar of life on Earth. Blue above, soft light, distant haze, breathable space, voices carried across a room, scents arriving on air, seasons announced by temperature and moisture. All of that enters thought before it becomes concept. To lose the atmosphere would therefore mean more than losing protection. It would mean losing the medium through which countless meanings arrive. The world would not only become dangerous, it would become less interpretable in human terms. Yet against that loss stands another truth, one quieter and perhaps more comforting. The fact that such a scenario can be analyzed at all means that the world is not arbitrary. The atmosphere obeys physics. Water responds lawfully to pressure and temperature. Radiation, heat flow, gas exchange, ecological collapse, planetary recovery all follow understandable patterns. There is no cruelty in the cosmos, only indifference and structure. That may sound cold, but it also means that our present world is not held together by magic. It is held together by real conditions, knowable conditions, conditions that scientists can measure and describe. To understand them is, in a modest way, to love the planet more accurately. And once accuracy deepens into feeling, a strange tenderness appears. The atmosphere stops being an abstract layer in a textbook and becomes what it has always been, the thin, moving, invisible sea in which all open earthly life is immersed. We say we live on land, but in a deeper physical sense, we live at the bottom of an ocean of gas. We walk beneath a pressure column. We speak through it. We depend on it. We are shaped by it. Even mountains, which look like symbols of solidity, rise into it and are softened by it. Even the sea, which seems so self-contained, shares its surface with it every moment. There is hardly an earthly thing untouched by air. That realization casts the whole thought experiment in a different light. At first, the question sounded dramatic because it threatened life. By the end, it becomes dramatic because it reveals what life has been quietly resting upon all along. The atmosphere rarely asks for our admiration. It surrounds everything so completely that it disappears from notice. It does not glitter like ice rings around a giant planet. It does not roar like an erupting
volcano. It does not expose ancient bones like an eroding cliff. It works anonymously, and yet its anonymity is the very reason life on the surface feels ordinary. Ordinary life is what a successful support system looks like. Without it,
Earth would still turn, sunlight would still arrive, the moon would still pull at the oceans, rocks would still fracture, volcanoes would still dream in the mantle, deep water might still hide pockets of endurance. But the open world of breath, weather, greenery, and sound would be gone. In its place, there would be a stern planet under black daylight, where ice sealed seas, where the remains of forests stood in silence, where cities endured as shells, where people, if they endured at all, did so by building small islands of artificial atmosphere against a larger emptiness. Perhaps that is why the final image of this imagined Earth feels so still. Not because nothing remains, but because so much of what remains lies beneath the surface, behind walls, under ice, inside rock, or far beyond human timescales. The loud phase has passed. The body's panic has passed. The cities have already stopped. The last visible green has faded. What stays is scale. A bare continent under hard sunlight, an ocean sleeping under frozen skin, a cratered desert where no wind lifts dust, a sealed habitat glowing softly in the dark, holding a few breaths like a secret. The planet continues, immense and patient, but it continues differently, and from that distance, the question turns gently back toward the living Earth we actually know, not as a warning shouted in urgency, but as a quiet correction to our sense of normal. The sky above us is not empty. The weather around us is not incidental. The ease with which we walk outside is not guaranteed by rock alone. Every ordinary day on Earth is a triumph of balances so ancient and so constant that they rarely ask to be noticed. We do not wake grateful for pressure. We do not usually thank the scattering of light for the blue vault overhead. We do not listen to wind as though it were evidence that the planet still remembers how to be alive. But in a way, all of those things deserve the patience of our attention. So imagine, one last time, that black sky over a quiet shore, the sea no longer moving in wind-driven rhythm, but resting beneath a new cold, the land clear and sharp in hard light, stripped of haze, stripped of weather, stripped of every easy sign that a world can carry life openly, somewhere far below rock, or under thickening ice, or inside one human-made chamber. Persistence may still exist. A machine hums, water circulates, air is measured, a lamp glows over sleeping faces. Beyond that small refuge, Earth turns soundlessly through sunlight and shadow, still beautiful, still vast, and no longer familiar. And then let that image soften. Let the sealed room fade. Let the frozen ocean darken into distance. Let the black sky become less a threat than a quiet ceiling over a planet resting in its altered state. No voices now, no traffic, no storms moving across oceans, no wind in trees, only the curve of the world carrying ice, stone, buried warmth, and the long memory of air. In that silence, the strangest part is not how quickly life would fail without the atmosphere. It is how completely life had trusted it while it was there, breath after breath, generation after generation, through forests and deserts and cities and ships and mountain villages and sleeping rooms. The whole human story unfolded inside a layer so thin, so delicate, and so faithful that most of us never once had to think about it. We were held by something invisible, and because it held so well, it disappeared. Maybe that is the final lesson hidden inside this impossible world. The most important parts of a planet are not always the parts that demand attention. Sometimes they are the quiet conditions that make attention possible in the first place. The atmosphere does not ask to be seen. It asks only to remain. And while it remains, oceans breathe, leaves turn sunlight into sugar, clouds gather over warm seas, distant mountains fade blue in evening light, and a sleeping species drifts through another ordinary night on Earth. So, beyond the thought experiment, beyond the frozen coasts and silent cities and sealed refuges under black noon, there is a simpler image waiting. A window left slightly open to cool air, a curtain moving almost imperceptibly, the faint sound of leaves outside, a sky
that will turn pale before morning. Moisture somewhere high above, gathering itself into cloud. Breath moving in and out without effort. Pressure resting softly on skin. The unseen sea of air still there, still carrying the world. And if the mind lingers on anything now, let it linger there, on the invisible thing that makes blue mornings possible, on the atmosphere above the roof, above the trees, above the sleeping streets, thinning slowly upward into darkness, yet thick enough here below to hold warmth, weather, voices, wings, and life. A fragile vastness, a quiet shelter, an ocean you never had to notice until you imagined it gone. Outside, the real Earth is still turning beneath it, patient and lit from one side, clouded and breathing, wrapped in the thin brightness that keeps stone from becoming only stone, and water from becoming only ice, and silence from taking everything. And somewhere over that turning world, in the dark above the air, the stars remain where they have always been, cold and clear and very far away, while down here, the unseen sky continues its gentle work, and the planet sleeps inside it.